about cystic fibrosis. Cystic fibrosis is a disease that affects children, teenagers, and sometimes even young adults as well. It's a very serious disease, even though people think that it's exclusively for people think that it's exclusively for the lungs because the lung manifestations are very common. But there are multiple systemic manifestations of cystic fibrosis that makes it a very, very serious disease and could lead to a lot of morbidity as well as death as well. Without any further ado, next slide please. This is the hero as well as the villain of this particular presentation, the CFTR protein, also known as the cystic fibrosis transmembrane regulator protein. Now, despite its complexity, it has only one function, very simple, anion transport. So what are the anions transported over here? Chloride as well as bicarbonate. Okay, that's it. Very simple, right? Cool. Now you might be wondering, why is that significant in this case? What can ion transport achieve? Next slide, please. What is its purpose basically? How can something so simple be so significant? Because it has maintained the fluidity of the semi-solid substances in the mucosa. Now you all know about the mucosa, right? The mucosa has a lot of different kinds of cells that secretes semi-solid substances. What are the semi-solid substances? Next please. Saliva, mucus, urine, semen, pancreatic fluids as well as bile, which are very important and very significant semi-solids in our body. There are various functions. Okay? Now since previous slides. Now why is this really important? Because these semi-solids have to stay as a semi-solid so that it can do its function properly. Because semi-solid is what? A solid as well as a liquid. Nothing much can be done about the solid part, but we can do a lot with the liquid part, right? Which means we can control these substances to do its various functions properly. Logically, for that, the level of fluidity has to be maintained, right? No matter what. And how is that possible? If you ensure the liquid content or the water content inside these semi-solids is maintained properly. Which brings me to the next slide. This blue line here is the mucosa. This is the CFTR protein and this is the epithelial sodium channel. E is for epithelial, C is for channel, Na is this natrium, which is the elemental name for sodium. Okay? CFTR is responsible for taking chloride from inside the cell and pushing it outside the cell. Okay? ENAC is responsible for taking sodium from outside the cell and taking it inside. Now, if you remember from physiology days, sodium and chloride are osmotically active, which means wherever they go, water will flow. Okay? Next slide, please. We see it over here. A hydration mechanism is set up in this case where chloride will ensure water goes from within the cell to this green substance here, which is the semi-solid of consideration. This could be anything, saliva, mucus, whatever. So this one hydrates the substance. ENAC with sodium dehydrates the substance. And when both of these forces are at the right balance with each other, this will have the right level of fluids, which means it can be controlled properly. If there's too much of water, hard to control, it becomes very slippery. If there's too less water, it becomes extremely difficult to move it around, okay, which could lead to complications. So far, so good. Okay, next please. Now you see this bicarbonate. CFTR is responsible for not just transporting chlorides but also bicarbonates as well. Okay, and there is significance here because chloride and bicarbonates, they act as a buffering system inside these solids here. What happens? The semi-solid has water, right? This is chloride, this is bicarbonate. They are now inside the semi-solid. These are in what form? They are conjugate bases. And they come from what acid? Hydrochloric acid as well as carbonic acid, right? So, inside the semi-solid, there is a rich mixture of bases as well as acids. With the help of water, they are in equilibrium and can shift between acidic and basic states anytime they want. Which means, because of the counter-ion effect, due to both of these ions, they act as a buffer. What does that mean? No matter where these things go, because there's mucosa everywhere, right? There are different environments, alkaline, acidic environments. This has to stay intact in those environments, right? So a buffering system is essential. That's why along with the hydration levels, thanks to these channels, the buffering system also ensures it stays intact no matter what. And like this, it does the normal function that is supposed to in the body. Which begs the question, how can things go wrong? Okay? Now, if the protein that I mentioned before is not made, or if it is made but is improper in nature, things can go wrong because of this one underlying mechanism here, impairment in chloride transfer. It's supposed to transfer chloride, it's not able to do that. So what do you think is going to happen? It won't happen. You might be thinking, so simple, right? How can this lead to complications? Trust me, this leads to a domino effect. Not domino effect is right. One small consequence lead to larger and larger consequences. This will lead to a domino effect that will eventually destroy multiple tissues in our body, and therefore, as we take it seriously next time. How does that happen? Now, CFAL is gone, or is not working properly, so there is no transfer of chloride ions over here, which means there is no water outflow from within the cells, but there is only a lot of reabsorption. So there is no mechanism to counter the reabsorption. Naturally, a lot of water content goes out of the semi-solid substance, making it more viscous and much more solid in nature. So therefore, this becomes much more viscid and tighter. We can't control it, we can't move it around properly. Next slide. We talked about bicarbonate, right? Chloride transport is gone, but bicarbonate has abnormal transport mechanisms where it doesn't go into the substance, it goes out into the excretory system and is thrown out, which leads to base deficit acidosis. Because of loss of base, which is the bicarbonate, that is an acidic environment in the body, which means the overall pH is going to be affected so much that there will be complications because of it. On top of that, bicarbonate and chloride, I told you that there are buffers. The buffering system is also now gone. So what do you think is going to happen? As this thing travels through an acidic environment, the bases get neutralized. And as it goes through an alkaline environment, the acids inside of it get neutralized. Acid and base gives you what? Salt, which is the precipitate. And therefore, there is precipitation of the substances inside the semi-solid, which causes even more solidification, to the point that eventually it becomes next a cyst. It was so hard they can actually call it a cyst. Now, is having a cyst a bad thing or is it a good thing? If it was a good thing, then this would be a physiology presentation, not a pathology presentation. So this is absolutely bad. Next step. Why is it bad? Because wherever the cyst forms, right, there is no movement. It can't do anything. It doesn't let the cells around it do anything as well, and cuts off its entire nutrient supply, therefore leading to ischemia. And if there's ischemia, eventually over a prolonged period of time, you get inflammation as well as necrosis. Add that to damage by the free radicals produced by various sources and the inflammatory cells like macrophages, neutrophils. That's going to be an exacerbated amount of damage. And if it happens in a permanent tissue, there won't be healing. What will that be in that case? Fibrosis, right? So this cyst causes fibrosis, and that is why this disease is called cystic fibrosis. So first of all, this is the basic mechanism that causes all the pathologies that you will learn in cystic fibrosis. Now all you have to do is transfer this knowledge to the different parts of the body that this affects. These are all the parts that it affects. So sweat glands, pancreas, salivary glands, lungs, heart, liver, intestine, sinuses. Okay, sinuses as in the facial sinus, as well as your vas deferens. All of these have a mucosa, they have secretions. If they become like a cyst, that's going to be complications and damage over here, which will lead to all those manifestations that you will read in detail in the office. Since this is a short 6-minute presentation, I don't think I can cover all of those manifestations, which is why they have been given to you as a further reading. These are all the topics that you could benefit by doing further reading. And I've given the page numbers as well. I want to share an interesting fact before I conclude. Cystic fibrosis has no infectious causes. Inflammation happens, but it's not because of infection, right? So there are no infectious causes. But there are infectious consequences, which means eventually a CF patient is going to face severe infections, not from any random bacteria, but from several resident bacteria like Pseudomonas aeruginosa, Haemophilus influenzae, Staphylococcus aureus, Burkholderia cepacia, and of course Clinotrophomonas maltophilis, which are all very resident bacteria, and antibiotics are not very much useful with them. And That's why scientists have figured out a way of using bacteriophages, which are viruses that consume bacteria, in order to kill these metastatic infection-causing bacteria. And now it's still under development. Eventually, hopefully in a decade or so, it becomes a mainstream form of treatment in cystic fibrosis. Next slide, please. I really hope I've done justice to this topic, and I hope you have found this insightful. Thank you.